Good morning, everybody. So welcome to the BDVE webinar series. Today we have the pleasure of having two speakers who are going to present how big data can be applied in the smart manufacturing industry, along with some example taken from the Boost 4.0 Lighthouse project from the Big Data PPP. But before giving the voice to them, allow me to say a few words about the webinar series. So this webinar is part of a series where we will be inviting speakers from different organizations and innovation projects to talk about their particular experience working with big data. By the way, in case you believe that you have a topic of interest for the audience and would like to be a speaker in one of our upcoming webinars, I take this opportunity to invite you to contact me anytime. The goal of this series of webinars is to show the value of big data, both from the technical and business perspective. So we will be touching a topic of interest for our community, such as lesson learned, best practices, innovative solutions, societal debates, etc. The idea is to run at least one webinar per month, typically on the first or second Tuesday at the same time as today. Although in some cases we will have a couple of webinars, such as in this month, where we are having two webinars. This URL at the bottom of the slide will provide you more information about the past and future webinars, as well as the recording and the slides that for webinars, including this one. After 1 or 2 days, they will be available in that URL. So some practical issues before jumping into the webinar. Please, if you have any question, write them in the chat. At the end of the presentation, the speaker will answer your questions if we have time for all of them. If not, we will try to also to answer them offline. I'm going to ask you a couple of questions to check the main interest of the audience, and also to give feedback to our speakers of the type of audience that we have today. And at the end of the webinar, you will be prompted with a couple of questions to give us recommendation and feedback. So the first question I would like to ask you, and this is a poll, is about if you are interested in technical aspects about big data. So I'm going to launch a poll, so please answer for a few seconds. The poll is already launched, and I will give you at the end of these few seconds the answers of the audience today. And this is mostly, as I said, to give some feedback to our speakers of the type of audience that we have. So I see that you are answering at this moment, so I give you a few more seconds. Okay, 2 more seconds, and I close the poll. So let me close the poll. Well, it's, I would say, half-half. It's 52% for big data technical issues and 48% for business or sector applications. So we have a mixed audience. And the second and last question is about your organization. I'm launching this question as well. And it's about if your organization is a provider of solutions for the manufacturing sector, or is interested in this solutions for the sector, or is actually applying solutions for manufacturing sector. You're the user of the solution for big data. So as in the previous case, I give you a few more seconds. Okay, I see that you're still answering, so 3 or 4 more seconds, and I will give you the total answer. Okay, I'm going to close the poll now. Okay, so it's 40% answer that you are providers of solutions. Another 40% are interested in solutions, and 20% that users or applying solutions for the manufacturing sector. So thank you very much for these answers, and this will give you will give people and the speakers the possibility of knowing the audience better. So without further delay, let me introduce today's webinar and speakers. So we have the pleasure of having two speakers, Davide Dalle Carbonare from engineering and Sergio Gusmeroli from Politecnico di Milano. Davide is going to give us an overview of the work done in the BDVA task force on smart manufacturing. while Sergio will give us some examples of the use of big data in the sector, mainly from the Boost 4.0 project, as I mentioned at the beginning. So without further delay, let me hand over to Davide. I'm going to give you, Davide, the presenter right, in order to show your screen. Okay. So just 1 second. So you should have now the control. So the floor is yours.
Okay. Hello, everybody. I guess you can see all my screen now.
Yes.
My name is Davide Dalle Carbonare, as just kindly introduced by Thomas. So thank you so much for your introduction, and thank you for hosting us in your webinar series. This first part of the webinar is dedicated to present you what we are doing in BDVA in the Smart Manufacturing Industry group. So this is a group inside the structure of BDVA. You see that in the picture on the right side. There are a number of task forces, and the one pointed by the arrow is the application one, when a number of vertical domains have been are actually discussed. So together with manufacturing, the one we are leading, me and Sergio, you can find also others like telco, healthcare, and others. So the group is quite populated. As you can see, we have more than 80 subscribed members. The main purpose of the group is to exchange views and learn from each other, from the experience that we do, and to collect all this knowledge in order to share and understand what's going on in the manufacturing domain and big data aspects in new countries. Thanks to this shared knowledge, we can also reach out a critical mass to be able to provide inputs to policymakers at EU level, but also at member states level. Each one of the members have their own connections at EU levels and at member states that help so much to collect information, to collect and share knowledge, but at the same time to feed back to them what is the outcome of this smart manufacturing group. And I'm going to talk about the main of this outcome. That's the discussion paper version 1. It has been released early last year, so early 2018. It's a discussion paper about big data challenges. So it's mostly focused on which are the main topics to be addressed in the domain of manufacturing that big data can solve. We've been looking for an alignment, of course, with the EFFRA, with Factory of the Future, because they are the most relevant player in the manufacturing scenario at EU level. And this document, of course, looked to be aligned with them, especially in what they call in the connected factories personas. We found them there: the smart factory, the smart product lifecycle, and the smart supply chain. I'm going to introduce them a bit later. This paper has been developed roughly in 50 months. We took advantage of a number of workshops and summits, all being organized by BDVA, and the activity groups, the periodic activity groups that BDVA organize to meet in person all the members and synchronize and progress the work. If you are interested in the paper, you can freely download it from the BDVA website. You can see at the bottom the link. So it's quite easy. You go directly to bdva.eu website, and under resources, you find a downloads page where all the papers produced by BDVA are published. So going down a bit more in detail on the content of this paper, I mentioned the personas from connected factories. We call them here ground scenarios, and they are the smart factory, the smart product lifecycle, and the smart supply chain. For each one of them, you can see here a number of aspects that are the main characteristics of those ground scenarios. You can see, of course, robots, machinery, and smart workspaces for what regards the factory. You can see aspects like circular economy, integration of data for the smart product lifecycle. While for the smart supply chain, you can find business aspects, human collaboration, and of course, all that comes from the supply chain aspects. Starting from this initial identification of the main aspect of the manufacturing process, we took from the BDVA SRIA, the very last version, the technical priorities. So we did this exercise. We crossed the 5 technical priorities identified by BDVA SRIA with the 3 main ground scenarios. Doing that, you can see here a matrix. These 15 boxes have been each one the cross for the ground scenarios and the technical priorities. So they are data management, of course, data processing architecture, data analytics mainly, data protection, and data visualization. For each one of these boxes, we run during the physical workshops post-it sessions in order to collect the most possible feedbacks from the community, from the BDVA community, but also from outside, thanks to the summits open to people from outside BDVA. And the result was to identify 56 challenges. Numbers of distributions are reported in those small boxes.
Davide, I think we are losing you. We cannot hear you well. I'm sorry, let's see if we can recover Davide. 1 second. It seems that David is having troubles. I don't know, Sergio, maybe you can take over for a while showing the examples and see if David can later continue. What do you think?
Okay, fine.
Okay, I'm going to give you presenter rights for the time being, and then let's see if David can recover this one. Okay, so Sergio, you can continue, and later we continue with David.
Okay. Good morning, everybody. My name is Sergio Gusmeroli from Politecnico Milano, and I was collaborating with Davide in the development of the discussion paper, version 1. And can you see my screen? Is okay?
Yeah, I can see your screen is the SMI discussion paper version 1.
Okay. And okay. Davide presented the version 1 of the discussion paper that we released last year with the main challenges for the 3 grand scenarios: smart factory, smart product life cycle, and smart supply chain. The point is that this year we have the version 2 of the discussion paper, and this version 2 of the discussion paper is extending the scope of the version 1, and it is focusing on other topics for which we have opened a discussion. The final target for this discussion paper is the European Big Data Value Forum in Helsinki in October. We aim to collect the contributions by summer and then to consolidate the contributions and to issue the recommendation in September so that we could have it ready for October. The main topics of this new edition are shown here, and there are the 6 bullets in this slide. First of all, we have these 56 technical challenges. The aim is to harmonize and prioritize these 55 so that we could really have a few technical challenges for each of the scenarios, which could be then transformed into recommendations, which is the last point. Recommendations basically for Digital Europe. Second point is that in this second edition, we are going to focus and to include non-technical challenges. And we are collecting contributions regarding basically 3 aspects of non-technical challenges. One is the aspect of regulatory aspects regarding big data for manufacturing, including legal and ethical issues. The second point is business and business innovation, how the introduction of big data technology could induce new business models for the manufacturing industry. For instance, servitization is one example. And the third aspect is related to the digital maturity or the data maturity of the manufacturing industry. And the point is also to see which are the skills which are needed for the manufacturing industry in order to implement this data-driven digital transformation of their processes, and if there are maybe new professions and new jobs that will be needed in order to implement. Third is, of course, the natural evolution of big data. And so we are aiming to create also a strong link with the Strategic Research, Innovation and Deployment Agenda on AI, which has been recently produced by BDVA in collaboration with EU Robotics. So there will be also a chapter which is related to AI, and in particular the point of data for AI in the manufacturing sectors. And by the way, there will be an important call in next year about AI for manufacturing in Horizon 2020. And of course, this is also this chapter will be also a good introductory document for those who are going to apply to this call. Number 4, we have selected some relevant topics which have been mostly suggested by our constituency, by our community, and in particular we choose digital twin as the topic of this year, and as topic of the year we are going to expect a contribution, that is how data technologies could contribute to the development of digital twins and their advanced applications like simulation, optimization, prediction, maintenance, zero defect manufacturing, energy management, and so on. As a matter of fact, we have also another point which is called data sharing spaces, and my speech will mostly focus on this last point, that is how data sharing spaces is currently addressed in one of the most important projects about big data for manufacturing, which is the BOOST Lighthouse project. Now I switch to my original presentation. Can you see my screen? Is okay?
Yes, you can see your screen.
Okay. So, as I said, one of the topics of the discussion paper of this year is about data sharing spaces. And in particular, this presentation aims to present you how the Lighthouse project, the BOOST, is addressing this important topic. This is not a presentation of the BOOST for the Zero project, and so maybe we could also have another webinar which will show in detail what the BOOST for the Zero project is aiming at, its technical achievements and its industrial pilots. In this aspect, in this presentation, I'm just focusing on one aspect, and the inspiration for this is a communication of the Commission last year, 25th of April, which speaks about towards a common European data space. So the topic to have a common European data space inside the digital single market is something that it is quite important for the Commission. It is not just a matter of free flow of non-personal data or GDPR for personal data. Here we are really addressing how to build and how to create this common European data space. In particular, for that, there was a guidance issued by the Commission about sharing private sector data in the European data economy. So the point is that European data space could be implemented in several different sectors. What this guidance is focusing is how to share private sector data and to allow a European data economy for industry. In particular, my speech will focus on the manufacturing industry because the BOOST project is about the manufacturing industry, but many of these considerations are also suitable for other industries, not just the manufacturing industry. In this document, the Commission basically identifies three main models to share data and to implement private sector data sharing for developing a European data economy. The first model, A, is an open data approach. And so, according to this approach, data are made available by the data supplier to an open range of users with few restrictions. So it is not just open for all, but we have very few restrictions. And in general, with no or very limited remuneration. The second model the communication is speaking about is data monetization on the data marketplace. And so the point is that the industry could sell data and get money out of this trade. And this is suitable when there are limited risk of illicit use of the data, when the data supplier has already some grounds to trust the users, the consumers, and when the data supplier has technical mechanisms to prevent or identify illicit use. The third mechanism is so-called data exchange in a closed platform, which means that we have trusted data networks where organizations are able to exchange data in a secure and trusted environment. I will briefly describe these three models with some examples taken from the manufacturing industry. Open data in manufacturing. If you speak of open data to the manufacturing industry, to manufacturing, they will not react usually positively. So the manufacturing industry is quite reluctant to embrace an open data policy. So my suggestion is to start step by step. And in this step-by-step approach, first of all, the first step, in my opinion, is to define open data models. And these open data models for manufacturing industrial assets like machinery, robots, AGVs, components, conveyors, or whatever you find in a plant, is, in my opinion, the best way to start this open data. So this open data process. So open data models where you put both Internet of Things data, data streams, and data coming from the enterprise systems, the so-called data rest. One example that we have in the Boost project is something similar to what FIWARE did for the FIWARE Lab data portal for Smart City. And so the point is to create really this library of open data models and to share these open data models in the community so that we could create the first data sharing space in the manufacturing industry. The second step, in my opinion, is to use this data in the network of didactic learning or training factories. You know that all around Europe, but also in the world, there are several of these factories which have been built with didactic purposes, both for students but also for SMEs, by implementing the test before invest paradigm. As a matter of fact, these data at the moment are not integrated, are not interoperable. And so data of experimentations that you do at Politecnico Milano Industry 4.0 Lab, which is the example here, or at the Smart Factory in Kaiserslautern, or at Automotive Innovation Center in Bilbao, or at the Patras teaching factories, at the moment they are not interoperable. And so a precondition for that is, of course, the open data models. Then gradually, I think we should also try to convince the manufacturing industry that on the one side, there are techniques, data transformation techniques, which now are AI-based, which are assuring anonymization, pseudonymization, aggregation, filtering. And then we should also maybe exploit the presence of the iSpaces community. iSpaces is a network of data infrastructures which are inside the Big Data Value Association. And the final aim is to create an ecosystem of innovators, and especially AI innovators. So, in my opinion, the message to be given to the manufacturing industry regarding open data is to create an ecosystem of innovators. That is, to provide the datasets properly anonymized, properly aggregated, properly secured, in order to build this ecosystem of innovators and to allow a data-driven and AI-driven innovation of their processes. The second point is data marketplace. And data marketplace, there are several data marketplace. In the manufacturing industry, I just put two examples. One example is an example taken from the digital innovation hubs. In my opinion, the digital innovation hubs should also offer to the SMEs access to data services. And so, as a matter of fact, in the manufacturing industry, the aggregation of SMEs in a digital innovation hub could also provide access to data so that the ecosystem of big data developers could be supported. Another case is what we are doing in another project, which is called Market 4.0. In the Market 4.0 project, we are going to develop a product, data, and service marketplace. So the basic point is that we don't have just to sell products, in this case, equipment, manufacturing equipment, but as a bundle, we could also sell data associated to this equipment and services associated to this equipment. Services which are typically useful before sale, which means configuration, nesting, simulation services, or also after sales, which are typically diagnosis, maintenance, and optimization services after sales. In this marketplace, we have three major actors. One on the left-hand side is the production equipment provider. On the right-hand side, you have the manufacturing industry or the system integrator, which is interested to buy this equipment. But we have a third actor, which is very important in the market, which is the service provider. And so the relationship and the business processes and the business models between these three stakeholders are analyzed in this Market 4.0 project. So that this, in my opinion, is very interesting for the manufacturing industry, and not just to sell data, so just a simple data marketplace, but a data marketplace which is connected to manufacturing equipment and to concrete value-added services. Regarding the trusted B2B data exchange, we have the reference architectural model for the IDSA. IDSA is the International Data Spaces Association. It was called Industrial Data Space previously. It is one of the beneficiaries of Boost, indeed. And the point here is to have this reference model whenever you have to exchange data between one organization and another organization. As a matter of fact, you have a data provider and a data consumer, a data source and a data sink to be linked, and the International Data Space reference architectural model is providing guidelines and reference model in order to implement this data exchange. There are several reference implementations of this already, and you can consult it in the IDSA website. As a matter of fact, this model is quite similar to the model that the Industrial Internet Consortium adopted for its reference architectural model 1.a, which is depicted on the right-hand side. So they say that we have 4 different vertical layers: machine, unit, site, and intersite. And for each of these layers, we have to provide a data bus, which is implementing the B2B data exchanges. As a matter of fact, a way to implement these B2B data exchanges are provided by the International Data Space reference architectural model. Another point which is more important and relevant for big data is to control the usage of the data that, for instance, are in a data repository or in a data lake. In this case, basically you have applications which should be included in a container, in a secure container, so that the data sovereignty principles and contracts are respected and constantly monitored and evaluated and assessed. This is specifically in the case of AI and the results of AI. Usually when you think about B2B data exchange, you think of raw data exchange, IoT data, but there is another aspect, which is what about the results of a prediction? What about the results of an optimization? What about the result, for instance, the point cloud of a 3D map digitalization, 3D scanning? So these are all data which maybe are even more confidential than the IoT data, and they are produced by applications, AI and big data applications. As well, we could consider also the explanation which brought the autonomous system, the application to these results. These are really pieces of knowledge which are very, very confidential and that need a specific trust mechanism. And in many of these cases, you cannot move the data. So you cannot transfer the data from a data lake to another data lake where there is the application. It is more convenient to move the application towards the data. And this is the case of this model. And we will see an example of this case in the Whirlpool industrial case of Boost. Last slide is that there is another publication from the BDVA, which is a position paper about towards a European data sharing space. It is worth reading it. It is not for manufacturing industry. It is really cross-domain, also in the B2C, in a B2C domain. And it is very important because we have developed some recommendation to be followed in order to implement a European data sharing space. And so the need of a technical framework which is going to support the development of these data sharing spaces, to consider data sharing as an integral part of the data lifecycle. And so it is not just data capturing, data cleaning, data processing, data protection, but there is also data sharing in the data lifecycle. And then there are some recommendations for Europe, basically. First of all, we need to create incentives for industry in order to share their data. And finally, we need a serious policy regarding data skills for Europe, and in particular for some industries, for the manufacturing industry in particular. Now I added the use case, the industrial case of Whirlpool in Boost, and I thank here the collaboration of Pierluigi Perlali from Whirlpool, who provided me with these slides. Which is the problem that Whirlpool is going to address? First of all, I think Whirlpool is very well known to everybody. They are producing home appliances, and the point here is in the spare parts management. And so the focus is not on the production, but is on the service. That is, we have the suppliers, of course, of the different pieces, for instance, of a washing machine. You have the production factory, and you have the transportation of the washing machine to the different homes where we are using these home appliances. As a matter of fact, these home appliances sometimes could also get broken. And so the point is to try to understand which are all the different fluxes of information which will allow us to build a prediction tool able to forecast when a specific home appliance is going to break. And as a matter of fact, the basic point is, of course, to create a better level of services for the consumers, but as an advantage for the company, the point is the reduction of the stock level so that we could keep spare parts in the warehouse in a more flexible and more intelligent way so that we keep just those spare parts which are needed. For that reason, in collaboration with SAS, we have developed this new prediction tool. The inputs of this prediction tool are several inputs, and these are really big data. First of all, we have factory data coming from the test done on the home appliances. We have the forecast of the sell-in and demand, service order confirmations. We have also a stream of smart appliances, that is those appliances which are connected via IoT. There are a few thousand of washing machines in Whirlpool that are currently sending constantly data to a central data center about the functioning of the smart appliances. And then we have the service incident rate. All this is processed by this new prediction tool prepared by SAS in order to produce the demand forecast for the spare parts and the quality reports for the Whirlpool people. As a matter of fact, now the point is what I mentioned before as data sharing. So what to do with the outputs of this prediction? The output of this prediction are not just important and fundamental for Whirlpool, but the output of this prediction are very important for the supply base, for the suppliers, and for the service in the field. And so the Whirlpool is in between a network of trusted tire suppliers and a network of trusted maintenance and field service providers. In this aspect, in Busto, we are going to implement this IDS reference architectural model, which is sharing the data coming out from the new prediction tool. And so this data is of extreme confidentiality level, and Whirlpool must be sure that this data is not misused by either the suppliers and the field service. This is still ongoing in the Boost project. The Boost project is more or less half of its way. We are at month 18 at the moment. And in this first 18 months for the Whirlpool use case, we have collected this data and we have run several iterations of the prediction tool. For the coming 18 months, we are going to implement basically this aspect, that is how to share the results of the prediction tool to the supply network and to the maintenance network. And this concludes my presentation. Thank you very much for your attention.
So thank you, Sergio, and thank you, Davide. I think Davide is already with us again, if I'm not mistaken. Davide, can you hear us as well, just to be sure that that you're there?
Yeah, I'm back. I apologize for everyone. Reliability of network connections is important, not only for manufacturing. And I would like to thank Sergio for closing for taking up my presentation.
Oh, sorry, Davide, if I expanded too much.
No.
Okay,
I guess
good.
you're perfectly on time.
Oh, this is a very nice picture of 30 years ago, more or less, for me.
Yeah, I wanted to have you in good shape, you know. Okay,
Right.
so thank you very much to both of you. I don't know if there are any questions from the audience. I think there's no questions so far in the chat. So if you have any questions, you can write them in the chat right now. I would like to ask in the meantime one question to both of you. You presented in the first presentation the BDVA task force around manufacturing. I wonder if you want more members to join the task force, or do you have something to share with the audience in order for them also to maybe to join if they are not part of the task force. So you can have your advertisement here.
Yes, of course. Of course, the main way is to be part of BDVA first, and then you can get access to all the content and all the activity that we do in BDVA, included the Smart Manufacturing Industry Group. If you don't want to join right now, but this is the strong advice, you can have some more information about what's going on by attending some events. Next week in Riga, for example, we are going to have a session there, and also in Helsinki in October for the European Big Data Value Forum. We are going to have a workshop there where we will present the second version of the paper that Sergio kindly presented in place of me. So those are the two main options. Of course, you can check BDVA website accordingly to your company or affiliation. There are different level of engagement with BDVA, and this is definitely the best way to get in touch, not only for the manufacturing part, but all the work we do around big data in verticals, but also in relation to upcoming framework programs from the EU and other activities based on research, but not only research, of course.
Okay, thank you very much. I think there's no questions on the chat, so I think we can finalize here. Just allow me just to remind you of the URL at the bottom of the slide, which is where we are having all the webinars, the recordings, and the presentations, and also the new registration for future webinars will be also posted there. So you, in a couple of days, you will have also the recording of this webinar. You can download it from there, and well, it's our place for having everything for the community in terms of webinars. So as there are no more questions, I think we can finalize here. So thank you very much to everybody for attending this webinar, and especially to Davide and Sergio for these fantastic presentations. Thank you very much.
Thank you, Thomas,
Okay,
and thanks to all the attendees.
Keep in touch.
Bye.